Sigma notation. Sigma notation is a shorthand way of writing a series. So you know that a series is actually the sum of a sequence, right? So any type of series is equal to term 1 plus term 2 plus term 3 plus term 4 dot dot dot. Sigma notation is how we can mean this, but we don't write it out like that. So let's have a look at the elements of sigma notation. Sigma notation has a very specific symbol, and it is this Greek letter that looks like an E. So the first thing you need to be able to do is be able to write this Greek sigma. The letter itself in Greek is sigma. That's the meaning of that E. Okay, now on the sigma notation, we have a couple of pieces of information. The sigma notation gives us a starting value, an ending value, and a formula. The first thing you need to know is that this TK tells us the formula. This is the formula attached to the series, whatever the series may be. You'll understand it better when we get to the next slide. Then we have this number 1 over here. This number 1 is our starting value, or the first value. This is where we start. Substituting. Okay. And then this over here is going to be our stopping value, or the last value. So it tells us exactly how many pieces do we go to. Okay. This letter K. This K is called an index, or the index of the sum. The number, the pink number 1, is going to be the start of the index, and the green N on the top is the end of the index. Okay, so right now it all sounds like nonsense, and that's okay. Let's apply it. Over here we have an example, which is the exact same one from above. And this tells us that we are going from the number 1 all the way to the number N. But okay, let's use a different question where it actually makes sense. On the screen, we have the sigma of 2k, where k equals 1 and n equals 5. Now, what does this mean? Let's start with this number 5 on the top. The number 5 tells me that we are going to stop at 5. Or, let's go ahead and do place values, okay? So we're going to say 1, 2, 3, 4, 5. At the moment, I'm doing 5, but it could be more, could be less. Let's just, in this example, it's definitely 5. Okay, what goes in these place values? You are going to look at this formula, and we are going to write 2 multiplied by k. 2 multiplied by k, 2 multiplied by k, 2 times k, 2 times k. Now, what's the value of k? K changes, and k has 2 values. It has a start value, so the first value of k is going to be 1. And the last value of k is going to be 5. And the values of k in between are just going to be adding up. So k increases by 1. If it starts at 1, then it's going to be 2, 3, 4, ending at 5. So these two numbers, this is my start for the substitute, and the second one is going to be my end for the substitute. This is the sum of the series that we're working with. So if you pop this into your calculator, or if you calculate it, you can figure it out, and you can say, okay, this gives me 2 plus 4, I didn't mean to write in green, plus 6 plus 8 plus 10, and the total of this is going to be 30. So in other words, sigma of 2k where k starts at 1 and ends at 5, is equal to 30. Let's do a second one. Now, according to this, we need to have a certain number. Let's do place value. So it's going to be something plus something plus something plus something plus something plus something. We don't know how many. So now what goes into those? The formula is going to be 2 exponent minus 1. 2 exponent minus 1. 2 space minus 1. 2 exponent minus 1. 2 exponent minus 1. 2 exponent minus 1. Now, we are going to start our exponent substitution with k is 3. And we're going to end when we reach the number 7. So 3, 4, 5, 6, 7. Or let's do 7 in green. This is where we want to end. Okay. So now what about the extra one that we wrote? That one does not apply. It doesn't exist. So our sigma here means what is written on the screen. So if you input that into your calculator, you will get 124. So in other words, we're not going to make 7 place values. It's not 7, because here we got 1, 2, 3, 4, 5. There's only 5 values. And that 5 is the difference between 7 minus 3 equals 5. There are 5 terms in the series. The first term is when we substitute the number 3. And you add 1 until you end at substituting the number 7. Next question. What if our value here is a number squared? So where do we begin? We are going to start at I is 3. So I'm substituting 3 and I square it because that's what my formula is, right? I squared. Then I'm going to continue until I reach the number 4. So it's going to be 3 squared plus substitute 4 and I square it. And that is just the total of this addition. So that's 9 plus 16, which is 25. And the fourth one, or the last one in this video, we are going to say, okay, this formula is a constant. There's no substitution, right? So the constant is 3. I've got no variables attached to it. My variable is r equals 1, or I'm starting at r equals 1. But my constant, I need to add from 1 to 20 terms. So if I say r is 1 and r is 20, that in total is going to give me 20 terms. Notice on this one, we said 7 minus 3 is 5, which is actually not true, right? 7 minus 3 is 4, but we are going to include. So let's say 7 minus 2 instead of 7 minus 5. So the same thing here, it's going to be that 20 minus 0, because we want to include the 1. So we want to have 20 terms here. That means I'm going to have 3, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19, 20. This is what the sigma notation means. This means I have basically 3 times 20, which is equal to 60. This is your basic introduction to what sigma notation means. This is not how we will use it, but this is just to understand what does the symbol actually mean. So in our next video, we're going to start using it properly.